Anyone else? This method by parts? No? No? Okay, so maybe this is new for most people. So we use the method of by parts when we have two things which are multiplied together. Leon, come on. Hi indeed. Right. So for example, what's wrong? This here is EX plus C. This one here is minus cos x plus C. So it makes you think that we should be able to do this one. You know, you think that we know what EX is, we know what sin x is, so why don't we know EX sin x? We have no rule for EX sin x, and substitution wouldn't work here. It doesn't make it simpler. So we have a new rule for today. Can I scroll down? Yeah. Okay, so there's many ways to write this rule. I like to write it like this. So when you want to integrate two functions which are multiplied by together, so the first one we'll call f derivative and the second one we'll call g. This is equal to fg minus f derivative g. And this formula is called fg derivative dx. And this formula is called by parts. Now, you might say, why is this formula useful? Because if you look at it, on the left we have an integration, and on the right we have an integration. So what this formula tries to do is it tries to take a hard integration and it tries to change it into an easier one. That's how this formula works, okay? It tries to make a more difficult integration into an easier integration. Now I'll give you the proof. The proof is quite short. Here's the proof. If I differentiate on the left, the derivative and the antiderivative cancel, and what am I left with? Just what's inside here. If I differentiate this, what rule do I have? What rule here? Product rule, yeah. F derivative g plus fg derivative, and if I differentiate here, it cancels the antiderivative, so what am I left with? Fg derivative. That cancels that, and that's the end of the proof. So like I said, it's a very short proof. More important now is an example of how to use this one. Okay, and before I do an example, I'll just remind you, if I go from this to this, that's called differentiating, and here to here, integration, or also called anti-differentiating. Okay, so just remember that. Right, can we do an example now? Let's do something not too difficult. Let's say we have something like this. X EX dx. Can I do this one now? So the way I like to do it is with a table. Or I should say, a lot of my students in the past prefer to do it with a table. It makes it clear what's going on. So what you do is you call this first piece here, this is the f derivative, and this is the g. So we have f derivative, g derivative.
How do you choose the g?
Oh, that would be another example, yeah. At the moment I'll just call the first one f and the second one g, but we'll get to the decision in a moment. Right, so what's f derivative? We know that's x, and what's g? EX. So now we must complete the table, which I'll do in blue. So if f derivative, what did I do wrong here? F derivative, I wrote the, yes, I think I wrote it back, I wrote it in the wrong slot. Let me just check something here. Sorry, I have my derivatives, well, not that it matters, but I want to match it up with the formula book. We usually put the derivative on the second one, so just tick the g and then tick the f. The proof is exactly the same though. Tick the g and then tick the f. Oh, well, no, that stays the same. Here. The tick is on the f. Anyways, that's just for the proof. Nobody cares about that. And instead it will cancel this one, and you're left with fg derivative, fg derivative. Anyways, just please make sure you change the formula. Not that there was anything wrong with the way you wrote it, it still works, but I want to match it up with the formula book. Usually in the formula book they put the derivative on the second one, not the first one. Okay, can I go back to the question? So I should have ticked this one, not this one. Okay. So what's the f here? X. And the g derivative? EX. Now in blue I finish the table. What's f derivative? Here to here? F derivative? 1. And then here to here, yeah, this is antiderivative. So this here is EX. And f to f derivative is derivative. So this rule is fg minus f derivative g. That's the rule.
Why EX is derivative, g derivative, not just g?
Yeah, the way this rule works is you call the first piece f and you call the second piece g derivative. If you call the first one f and the second one g, it doesn't do anything to make it easier. Okay, can I scroll down a little bit? Okay, so what's f? That's x. And what's g? EX. And f derivative? 1. And g? EX. Has the problem become simpler now? Yeah. Because now we only have to integrate EX. That's much easier to do. So you're left with x EX minus EX plus C. I'll do another example. Doesn't matter. Yeah. Question? Yeah. Can I do another one? So let's try this one for example. X sine x dx. this we'll call f, and this we'll call g derivative. F derivative, g derivative. So we know what the f is, it's x. And we know what the g derivative is, it's sine x. Okay, what's f derivative? 1. And g? Very good, minus cos x. So the rule is this is the same as fg minus f derivative g dx. So using my table now, this will be fg minus f derivative, and the g is a minus again. So this will be minus x cos x plus integrate cos x dx. So what do we get there when we integrate the cos x? Sin x plus c.
Why is not minus cos x?
Where? Here? There were two minuses.
No.
In the box?
No, in the, like, above the second line.
Here?
The,
Ah.
Minus.
now,
Yeah. Continue. Now, let me give you one to try by yourself. Log x multiplied by x dx. Try this. In the formula book, they write it differently. I'll talk about that nearer to the exam. Finished? Some people finished? Let's have a look. So we call this one f and this one g derivative. So f derivative g derivative. So that would be log x, and the derivative 1 over x. And then g derivative is x, and g
1 over 2 x
squared. Yeah. So this equals fg minus f derivative g log x, a half x squared minus 1 over x times a half x squared. So that's a half x squared log x minus a half integrate x. Because, of course, the x will cancel the square here. And that's easy. This is easy to do here. A half x squared log x minus a half x squared plus c. So finally, a half x squared log x minus a quarter x squared plus c. Yeah. Yes. Yes. Now, there's still more examples to do. Does the order matter? For example, if I wrote down x log x and I wrote down log x dx, this is the one we just did. That was okay. And this one is the same. The only difference is I swapped the x and the log x. But you'll notice that it's more difficult this way because f is x and f derivative is 1 and g derivative is log x and g is, no, we don't know. In fact, we don't know what the antiderivative of log x is. We've never done it. We've only done the derivative of log x, not the antiderivative. So actually it does matter which way around it is. Sometimes you need to swap them, like for example, sine x multiply ex or ex multiply sine x. They're the same, but this one is easy to do and this one is not. So how do you know which way to put it? Well, this is what I want to show you next. If you can remember this word, so this is the order you should use. The L stands for logs, so you always have logs at the front if you can. The I stands for inverse, sine inverse, cos inverse, tan inverse. They should come next. The A stands for algebra, like x squared, 1 over square root x. The T stands for trigonometry, sine x, cos x, tan x. And lastly, the E stands for ex. So you should try to put the problem in this order. This will be the easiest order to work with. Okay, can I scroll down? Not yet, no. Have you seen this before? Remo, have you seen this before? No. Malik? No, okay. Scroll down now. Right, try this one for me. Cos x multiplied by x squared. Try this. Yeah.
Too long.
Not too long. Let's have a look. So the first thing I need to do is swap them, because the A is before the T. L-I-A-T. This is F and this is G derivative. So I draw my table. Let's try that again. I draw my table. F derivative, G derivative. F is x squared, F derivative is 2x, G derivative is cos x, so G is sin x. And this equals F G minus F derivative G. Now you notice that the problem is easier but not easy enough. Yeah, why did I write that? Because I am hungry and tired. Sin x dx. Yes? Now, the problem is easier but not easy enough. What do we need to do next?
Do it again.
Again, yes. So let me just clean it up a little bit. This will be 2x sin x dx. So on this part we use our rule again. F is x, F derivative is 1, G derivative is sin x, and what's G? minus cos x. Yeah. So now this becomes x squared sine x minus 2. And then inside here we have f g minus f derivative g again. So this will be x squared sine x plus 2x cos x minus is minus 2 cos x dx. So after using the rule twice, it's now easy enough to finish. Last line, x squared sine x plus 2x cos x minus 2 sine x, yeah, plus c. Oh, it's a little bit. Leon, can you move this a little to the left? Left, yeah, more, yeah. Okay. You have this one? Let me give you, I want to do 2 more examples and then you can try some. 2 more that you could get in the exam. So in the exam, usually you need to use the rule twice. Sometimes once, usually twice. Can I scroll down? Okay, try this one for me, please. Integrate, let's say, ex cos x dx. Okay, try this one. It's a strange one, yeah?
Which one comes first? Sine or the...
What do you mean?
When you integrate everything together. Cos x sine x.
You have a cos x sine x? Oh dear. I think you did something wrong.
Oh.
Got it? It's a bit difficult, yeah? Do you notice what's happening with it? What's happening? So just please continue forever doing this. Don't let me stop you. Okay, let's have a look at this one. So do I need to swap? Yeah, well, yes or no? Yeah, I need to swap. So firstly, change this into cos x ex dx, because the L-I-A-T-E, the E is always last. This is f and this is g derivative. F is cos x, f derivative is minus sin x, g derivative is ex and g is ex. Okay, so now we have cos x ex dx equals f g minus f derivative g. So take the minus out, correct? Yep. Cos x ex plus sin x ex dx. So we need the rule again. G derivative is ex and g is ex. F is sin x and f derivative is cos x. Yeah. Okay. So now this equals cos x ex plus f g minus f derivative g. Is that right? Yeah. Yeah. So this equals cos x ex plus sin x ex minus cos x ex dx. I'm back to the start. It's a problem. Does anyone know what to do next? Oh, no.
I think it has no answer.
Oh no, it has an answer. So watch this. Let's not forget what is equal to the question. Cos x ex dx is equal to this. Yeah. Take this over here. How many of them do you have now? Two of them. So now I have 2 cos x ex dx equals cos x ex plus sin x ex. What's next? Interesting, yeah? This I have seen on the exam before. And the next one I'm going to do, I also have seen on the exam. Can I scroll down? Now, if you remember, I said earlier we do not have a rule for log x antiderivative, but we can use our formula for today, except there's something missing here. What's missing in this question?
1.
Yeah, I'm missing another number because I need 2. So, like Leon said, I should put in maybe a 1 here, 1 log x. Is the order correct or not? Do I need to change it or not change it? Change it? Yep, because log is always first. This is f and this is g derivative. F derivative, g derivative. G derivative is 1, so what's g? What's g? X. F is log x, so what's f derivative? 1 over x. So this equals f g minus f derivative times g. Now that's nice because here the x's cancel in the formula. So you're left with x log x minus integrate 1 dx. Now what's this here? It's just x, isn't it? So you're left with x log x minus x plus c. That's the answer to that. So I've seen this in the exam. They usually do it with log x, and the other one, which is in the workbook, is with tan inverse x. I suppose you could also have sine inverse and cos inverse. Now, when this came up in the exam, maybe 3 years ago, I thought it was a little bit unfair because the question was written like this. The question was just calculate or simplify this. Nobody got it because the question didn't give you any hint. Yeah, the question didn't say hint, use by parts. It didn't say that. Or it didn't say let log x equal log x multiply 1. It didn't say that. So it meant exactly 0 students got this. Even though I did this example in class, nobody remembered the trick here was to change it into log x multiply 1. So what I'm trying to say is in the exam, sometimes you get questions like what I do in class, but they become very difficult because you don't know which lesson it's coming from, you know. So this is why it's important to practice them at home so that you can remember what to do if you see it in the exam, okay? Because I know you think, oh, this looks easy, maybe, but it's not easy if you don't remember what to do in the exam, that this is a by parts problem. So it's important to practice. Also, sometimes you have limits, and if, for example, you had limits here, like let's say 1 to 2, the limits go in at the very end after you simplify. You can forget about the c and you can put the limits in at the very end, okay? So if there's limits, they go in at the very, very end. Okay? Right, can you try some of these for a few minutes before we do the next lesson, okay? These are all like exam questions. Every question here has been or could be on your exam. Everything. Can I close this?